You were there for all of it. Learning to walk, your mother's face at 6 months, the first time you understood a word. Thousands of hours of the most important period of your life, the years that literally built your brain, and you cannot retrieve a single second of it. No image, no sound, no feeling, nothing. That strangeness deserves a moment. We spend years becoming human. Those years matter more than any other stretch of your life. They shaped your nervous system, your capacity to trust, your ability to learn language, to move through space. Everything that follows is built on that foundation, and the foundation itself is gone. You might think that's just how memory works, that infants lack the wiring, that their brains aren't finished developing yet, that nothing was ever recorded in the first place. For a long time, that was the answer everyone agreed on. The old answer is called the hippocampal maturation hypothesis. Here's how it worked. The hippocampus is the brain region that encodes episodic memories, the specific events you can recall. And the hippocampus doesn't finish developing until you're well into adolescence, sometimes even into your 20s. If the hardware isn't complete, the thinking went, then the recording equipment doesn't work. Infants don't encode memories because they can't. There's no tape. The blank space in your mind isn't a gap in retrieval. It's the absence of storage. Nothing was ever saved. This idea had weight. It was in textbooks. It was taught to neuroscientists. It was, for decades, the settled answer to why you can't remember being a baby. Then in March of 2025, a team at Yale published a study that reversed it entirely. The researchers were Tristan Yates and colleagues working in Nick Turk-Brown's lab. Their question was simple: do infants actually encode memories? Can that hippocampus, young as it is, do the job? To answer it, they scanned awake infants using fMRI while those infants watched photographs. Some photos were new, some the infants had seen before. The researchers measured hippocampal activity, electrical firing in that region, while the babies looked. Then they asked, does that activity predict whether the infant will look longer at a photograph later? Looking longer is the standard test of infant recognition. If an infant remembers something, it looks at it more. The answer was yes. Greater hippocampal activity while viewing a previously seen photograph predicted that the infant would look longer at it later. The encoding worked. The hardware was functional. Infants as young as 1 year old showed this pattern. But here's what made this study different from others. You cannot tell a baby to hold still inside an MRI machine. The scanner is loud. It's confined. It's weird. Babies don't cooperate. So the team used pacifiers, blankets, stuffed animals. They propped infants steady with pillows. They played psychedelic background patterns on screens to hold attention. Even with all of that, babies wriggled, they shifted, they moved in ways that ruined the scans. The researchers didn't give up. They simply ran more sessions, hundreds of them. They've now passed 750 infant scans to get enough usable data. 750 times they sedated no one. They didn't paralyze anyone. They just kept showing up with pacifiers and blankets and pattern-filled screens, letting babies fail, collecting the successes. The result is clear. Infants encode. The recording equipment works. That changes everything, because now the mystery isn't blank tape. It's retrieval. If infants are making the recording, then the memories are being stored somewhere, but you can't access them. The information is there, you just can't reach it. There's evidence for this from other animals. Researchers studying mice found that rodents learning where an escape hole is located during infancy forget it by adulthood. The memory is gone until scientists use a technique called optogenetics to reactivate the neural circuits that hold that memory trace. Then the mouse remembers. The pathway is restored. It was there the whole time. Now I need to be direct about something. The idea that you still hold your infant memories somewhere in your brain is Tristan Yates's speculation. It's not a conclusion of the study. The research shows that infants encode. It does not show that those traces survive into adulthood. That's the possibility. That's not the same as proof, but the possibility is extraordinary, because for 100 years the answer was, there's nothing to remember. No recording was made. You were blank. Now the best available evidence from neuroscience says the recording was made, which means the absence you experience, that complete void from your first 3 years of life, is not an absence at all. It's a retrieval failure. Somewhere in your brain, the years that shaped you most profoundly may still exist, as electrical patterns, as neural traces, as preserved information you cannot access and may never access. Your mother's face at 6 months might be stored in circuits you inherited. Your first word, the day you learned to walk, the thousands of hours of being alive before you could form a narrative about being alive. All of it recorded, all of it locked away. Think about what you've forgotten in your life, moments you tried to hold on to and couldn't, people you loved and lost from memory. They're gone because you didn't encode them, or because the traces decayed, or because you simply can't retrieve them anymore. But your infancy might not be like that. You might have encoded it perfectly. Your brain did the work. The information is there. You just can't knock on the door and ask to come in.